Unit 7, Chapter 10.3, Solving Equations that Require Two Steps. The previous two sections of this unit each required one step to isolate the variable. In this section, it's going to require two. And the reason is there will be two numbers on the side with the variable. So if this is our variable term, then we'll have some value that's being added or subtracted, represented by this plus b. And there may also be a second number that is multiplying or dividing the x. And so what we will do is apply the principles we learned in the first two sections to solve these equations. So the first step we will do is use the addition property to isolate the variable term. Now the variable term is the variable plus the a, or the coefficient. So if this is the variable term, the first thing we want to eliminate is the b. If the b is being added, we would subtract it. That's why we use that addition property first. It's important you do it in this order. And then the second step, or the last step, is once we have isolated the variable term, so in this case now we have the ax is equal to some number. I'll just put a number sign there. Then we're going to use that multiplication property to isolate the variable, which means we will go ahead and divide both sides by the a. So it's just the two previous sections combined together. So our first example, we have 2x plus 4 is equal to 12. Well, step one, we want to use the addition property to isolate the variable term. So to be sure we understand, this right here is the variable term. So that means the 4 must be eliminated first. So using the addition property, that means we're going to go ahead and subtract the 4 to eliminate it. And then the property of equality says we got to do it to both sides. And so when we do that, I did nothing to this first term, the variable term. Plus 4 minus 4 is 0. Adding 0 to anything has no effect, so I won't write it. 12 minus 4 is 8. So step 1, I've eliminated the 4. Step 2, use the multiplication property to isolate the variable. So here is the variable. The whole thing is the variable term. So now I attack the 2. Well, since the 2 multiplies the variable, I will divide by exactly that number. I must do it to both sides. 2 divided by 2 is 1. 1 times x is just x. 8 divided by 2 is 4. How do I know the answer is correct? I can always plug it in to the original equation. So the original equation was 2 times x, which we have claimed that x is now equal to 4. Plus 4 is equal to 12. 2 times 4 is 8. Plus 4 is equal to 12. 8 plus 4 is 12. 12 does equal 12. The answer checks correct. Another example. Negative 3x minus 5 is equal to 16. Step 1. Use the addition property to isolate the variable term. Here's my variable term. So I want to get rid of the minus 5 first. So I will add 5 to both sides to keep the equation balanced. I didn't do anything to the negative 3x. Minus 5 plus 5 is 0. Adding 0 has no effect, so I won't write it, but these are eliminated. And 16 plus 5 is 21. Step 2, use the multiplication property to isolate the variable. So that means I must eliminate the negative 3 that is multiplying the x. Using the multiplication property means I divide by exactly the same number. Must do it to both sides. Negative 3 divided by negative 3 is a positive 1. 1 times x is just x. And 21 divided by a negative 3 is a negative 7. Is my answer correct? Let's plug it back into the original equation. Negative 3 times a negative 7 minus 5 is equal to 16. Order of operations, I multiply first. Negative 3 times negative 7 is a positive 21. Minus 5 is equal to 16. 21 minus 5 is equal to 16. 16 equals 16 is a true statement. The answer checks to be correct. One last problem. Step 1, isolate the variable term. Here's the variable term. To isolate that term, I have to eliminate the plus 10, so I'll use the addition property and the property of doing the same thing to both sides of the equation. So I'll bring down my 8x. Minus 10 plus 10 is 0, so adding 0 has no effect. So I've effectively eliminated the 10. 34 minus 10 is a positive 24. Step 2 is go ahead and use the multiplication principle to isolate the variable. That means I'm going to divide both sides by 8. 8 divided by 8 is 1. 1 times x is equal to x. 24 divided by 8 is 3. Is the answer correct? Let's plug it back in to the original equation. 8 times 3 plus 10 is equal to 34. In order of operations, 8 times 3 is done first. That's 24 plus 10 equals 34. 24 plus 10 is equal to 34. 34 does equal 34, so the answer is correct. That concludes this section. Okay, we will begin to complicate this slightly by adding an additional step. In the previous parts, we had step 1 and 2. Step 1 was isolate the variable term on one side using the addition property. That is now going to be step 2. The previous step 2 was isolate the variable using the multiplication property of equality. That is now going to be step 3, and so we will introduce a new step 1, which is the before you do step 2 and 3, you must simplify each side separately. Now, by each side, we mean each side of the equation or the equal sign. And what we do is we clear or eliminate parentheses, and I will explain that in a minute using the distributive property, which I will explain. And then we combine like terms. Once we have completed that, then we will proceed as we did in the previous section. Here is an example. Notice the equation written here, and what you will also notice is that I'm going to put a line here on the equal sign just to show it distinctly, that on the left side of the equal sign we have two terms that contain w's, and we have two terms that are just numbers. And in step 1, when we say simplify each side, in this case without parentheses, we must combine together like terms. Like terms means those terms which are the same. W terms and W term here are both the same. Numbers are both the same, and so we combine these together. So if we have 5W and we also have a minus 2W on the same side of this equal sign, it makes sense that we really only are going to have 3 W's. 5 minus 2 would be 3. Likewise, if we take the plus 3 and we subtract 7, would give us a net negative 4 on the left side. So let's go ahead and do that simplification. So here you see the result. The 5 minus the 2 resulted in a 3W, plus 3 minus 7 resulted in negative 4. On the right side of the equation, there is nothing to simplify. So at this point we have completed step 1, and then we proceed as we did previously. On to step 2, well, we want to isolate the variable to one side and numbers to the other using the addition property. So I will go ahead and eliminate the negative 4 by adding 4 to both sides of the equation. When I do that, I'm left with just the 3W on the left, because minus 4 plus 4 is 0. Adding 0 has no effect. On the right side, when I add 4, that adds to 12. I am not finished with step 2 because I have to get my W term, or my variable term, to the other side. So to eliminate it from the right side, I will subtract 6W. I must do the same thing to both sides. And when I combine those terms together, 3 minus 6 yields a negative 3W, or minus 3W. and these w's cancel each other out to 0, leaving me just a 12. Step 2 is complete. On to step 3, I will eliminate or isolate the variable using the multiplication property. So to eliminate the -3, which is the coefficient of the w, I will divide by -3. I must do it to both sides, and when I finish doing the division, the result is I now have the w, or the variable, isolated by itself with a number on the other side, so I have solved the equation. You check the equation by substituting in your solution for the variable. So here's the original equation. I'm going to click through this quickly. I replace w with -4. I then do the multiplication first, the order of operations resulting in this, and you can check this. And when I combine the left and the right side of the equation, I get -16 on both sides, which means the solution is correct because -16 does equal -16. Here's another equation. Let me highlight the equal sign, because step 1 is to simplify each side of the equation. So I must simplify what's on the left, simplify what's on the right. Now notice there's nothing to simplify on the right because I have an h term and a number. There's nothing to combine together. On the left, however, I have a set of parentheses and a number 5 multiplying whatever is in the parentheses. For me to simplify this, since I don't know the value of h, I cannot combine h minus 4. So the way that we eliminate parentheses is through distribution. What is distribution? Well, distribution is simply multiplying the coefficient, in this case the 5, that's on the outside of the parentheses. I multiply it with every term inside the parentheses. So when I do that, 5 times h is 5h. 5 times a -4, a positive times a negative, is a -20. And notice the parentheses are gone, and then I just bring down the +2 and I rewrite the right side of the equation. So I've eliminated the parentheses, but I still have terms to combine together on the left because I have these two numbers. So -20 and +2 combines to get -18. I have simplified the left side completely because there's a variable term and a number, and the right side is already simplified. So now I go on to step 2. I want to isolate the variable term to one side and numbers to the other, so I will eliminate the -18 on the left side by adding 18 to both sides. When I do that, I'm only left with 5h on the left. I bring the 3h down. -4 plus 18 results in a positive 14. Now I must get my variable term to the other side, which means I must eliminate the 3h by subtracting it. So I subtract 3h from both sides. 5 minus 3 results in 2h, and I'm left with the 14 on the right since the h's canceled each other out. Step 2 is complete. Step 3, isolate the variable using the multiplication property. Since 2 is multiplying the h, I will divide both sides by 2. And when I complete that step, variable is by itself and a number is on the other side, so that is my solution. I can check the solution by substituting 7 for h into the original equation. Once again, I will click through this quickly. There's the original. I replace h with 7. I then, using the order of operations, I would do what's in parentheses. Now I can do that because they're just numbers. And so I replace 7 minus 4 with 3. I'll do the multiplication next and then combine the numbers, and I get 17 is equal to 17, which is true. Therefore, the solution to the equation is 7. Here is one last example. Notice that this is a much more complicated equation than you've seen previously. I'm going to highlight the difference between the left side and the right side by drawing this line through the equal sign. Notice on the left I have a set of parentheses. I know I have to simplify this. On the right I have a set of parentheses. So I will simplify both sides of the equation. So on the left, to eliminate the parentheses, I have to distribute. Well, here there is no number. Well, in reality, there is an implied 1 if you do not see a number. So we will distribute -1 through the parentheses. On the right side, we have a 2 that we will distribute through those parentheses. So again, distribution means repeated multiplication of the coefficient on the outside with the terms on the inside. So when I do that, I bring down my 15y. -1 times 10 is -10y. -1 times a -2 is a +2. And then on the other side of the equal sign, 2 times 5, that would yield a 10y. And then 2 times 7 is 14. So the parentheses are eliminated. Now I combine like terms. On the left side, 15y minus 10y combine to be just 5y. 2 is the only number on the left. 10y is the only variable term on the right. Plus 14 minus 16 adds to -2. I have now simplified each side of the equation. On to step 2, I want to isolate the variable one side and number on the other using the addition property. So I will eliminate the 2 on the left by subtracting 2 from both sides. That yields just a 5y on the left, 10y minus 4 on the right. I want to get the variable term on the left side, which means I eliminate the 10y on the right side by subtracting it. And when I combine like terms, 5 minus 10 is a -5y. And all I have left on the right is the -4. Step 2 is complete. Step 3 is isolate the variable using the multiplication property. I will divide each side by -5. And when I do that, I get y is equal to a +4/5. Again, a negative divided by a negative is a positive. It is quite possible to get a fraction as an answer. I will not show step 4, but step 4 is to plug 4/5 into the original equation and see that you get two things that equal each other. That concludes this section.